Hello and welcome back to Math 100. Today we are going to start a new chapter, chapter 2, that is on mathematics and numbers. Now you may think that, hey, mathematics and numbers, or all math is about numbers. Well, actually it's not true. Math is about a lot more than numbers, and you will see what I mean for the rest of the semester. But for chapter 2, the main topic would be numbers, and we start with something very practical in terms of percentages. So for this first section, section 2.1, our focus will be on percentages, and in particular, the basic notions of percentages. And in the next section, we'll talk about some interesting, perhaps useful and abuses of percentages. But that's for the next section. Today, we look at the basic concepts involving percentages in section 2.1. So let's go ahead and get started. I will share my screen as usual. All right, so here we are in section 2.1. I hope you have your outline, basically your blank notes sheet available in front of you so that you can take notes as you watch these videos. All right, the topic, let me go to my writing. And so my topic of 2.1 is, as I said, basics of percentages, okay? And now, if you, let me go ahead and go to the questions. How do you solve percentage problems? Okay, now if you think, okay, I know all about percentages, this will be an easy lesson for you. If you are one of those students who say, well, percentages, I don't remember anything about this. Maybe this will be a lesson where you want to spend a lot of time on, okay? And just so you know, we do have extra support available for these calculation or arithmetic intensive sections. So extra support and resources are available for this lesson. Ask your instructor. Well, let me tell you what's available is I'm going to write this down here. We have a pretty extensive group of non-credit classes, okay? So in particular, if you are to look at our non-credit offerings, so, go to canyons.edu and search for sections or search for courses as you would for other courses. And instead of looking for math courses, go to non-credit math courses. Okay, so that's a completely separate division. And under non-credit math, you'll find NC non-credit math 004. And 004 is the non-credit support class for percentages. Okay, so this will be quite useful. This is completely free. It's not going to affect your transcript in any ways, but this will provide extra support that you may need to brush up on your arithmetic skills involving percentages. Now, what is a percentage? Well, it's basically that, percent, okay, which means 1 out of 100. It's basically 100th. That's what a percent means. And percentages are used extensively. You probably will not spend a day without seeing or using or reading about percentages. This is used to indicate parts, portions, changes, and comparing two things, like finding difference between two things. You can say, for instance, that something's increased by such and such percent, or that the product A costs 20% more than product B, and so on. Here's the basic equation. Okay, now this one you do have to know. And so I'm going to write this down. Let me go ahead and use my handwriting, because that's a little easier when we write mathematical notation. All right, so you know what this is? A over B, okay? And that basically means A divided by B, okay? When you divide the number A by B, you can write that as a fraction, A over B. And this is P over 100. So this is, of course, P divided by 100, where P is the percentage. Now, this is a little tricky, so I will, of course, explain this. A is the part that we are dealing with. B is the whole. Now, the word whole is sort of misleading. I will be using the word whole, the word base, and the word reference, all to mean the same thing. It is the denominator where the numerator, A, is the number that represents the part of the whole, which is B. Okay, so A over B, if we say it is 50%, if A is 50% of B, then this P number will be 50 over 10, which is 50%. Okay, so P in this case is a percentage. Now, having said this, though, the key idea is this, okay? Do not use this number P percentage as is. Use the decimal equivalent for percentage calculation. So for instance, when you say 5%, that is 0.05. Okay, so what you have to do is to divide this number in front of the percentage sign by 100. 5 divided by 100 is 0.05. And I want you to know the number, the decimal number 0.05 is precisely equal to 5%. And when we say 5%, we precisely means 0.05, the decimal number. Similar thing can be said about 72%. 72% can be written and should be written as 0.72. Okay. Now, in all of our calculations involving percentages, this is the convention that we will follow. Okay, so make sure you know how to convert from a decimal to a percentage and vice versa. Okay, that's actually not difficult, right? 72%, all you have to do is to put the little decimal sign or decimal point before that number 72. Or equivalently, you just divide the percentage number 72 by 100 to get 0.72. Okay, so in that sense, 1% is precisely equal to 1/100th, which you can write as 0.01, and that is 1%. All right, let me give you an example. I know that most of you can do many of these things, but if you don't, no pressure. You can learn these simple arithmetic matters quite easily and quickly. Let's go with some a very simple question. What is 45% of 100? The answer is, of course, 45. How do you get that? Well, remember, 45% can be written as and should be written as 0.05. And if you're looking for the part, which is the A number here, then all you have to do is to multiply the reference number by the percentage written as a decimal, 0.45 times 100, and that is 45. 45% of 700 is what? Okay, what is that one? Pretty much the same idea, 0.45, which is 45%, times 700, which is 315. Okay, now I have no problem with you using a calculator. So use a calculator for these calculations. And if you don't own a calculator, you can use your cell phone because pretty much every cell phone is equipped with a calculator. On an iPhone, if you open your calculator app and if you put your phone on the sideways in the portrait orientation, that simple calculator becomes a scientific calculator, which you can use later for more complicated calculations. All right, the next one, 3/8 is what percent? Okay, so how do you find that? Well, 3/8, if this number is 3/8, the question is, what percentage is that? Okay, and all you have to do is to just divide 3 by 8. Okay, and that's going to give you 0.375. Okay, and that is the decimal equivalent of this answer. And of course, 0.375 is 37.5%. Right. How do we get that? Well, we multiply this decimal by 100, which is equivalent to moving the decimal point 2 places to the right. And that is how you convert a decimal number to a percentage. Okay, so 0.375 as a decimal number is equivalent to or equal to 37.5%. Okay, So that is 0.375 written as a decimal number. Sometimes you are asked to find the percentage, just like this one. This one is like, okay, so for number 2, a word question may be, if 3 people out of 8 made a payment, what percent of the people made the payment? If it's 3 out of 8, and you say, well, that's 37.5%. Simple, right? 3 is the part, 8 is the whole, or the reference, as I said before. Number 3, 30 out of 1,500 is what percent? Okay, so let's say 30 people are missing out of 100, out of 1,500 people. What percent of the people are missing at the moment? Well, anytime you look for percentage, you are dividing the part by the whole. Okay, and when you do this division, you'll get 0.02. Okay, that is the decimal answer. 0.02 of 1,500 people are missing or so on. But what percentage is that? 0.02, the decimal number is exactly same as 2%, because again, all you have to do to go from a decimal to a percentage is to move that decimal point 2 places to the right to get your percentage. So you can say at this point, 2% of the 1,500 people are missing at the moment, or whatever. Okay, number 4, if 27% of all students is 810, then the entire student population is blank. Okay, let's say 20% of all the students are seniors in a particular high school. 27% of all the student body are seniors, and that's 810 seniors at this high school. Then what is the student population? Notice here, this is a percentage, right? And all the students, well, all students, we are missing the base number, the reference number. Now we know that 27% apart is equal to 810 people. So the idea is this: you have 810 people divided by some number we don't know. That's the reference number B is 0.27 or 27%. Okay, remember this is at the beginning, what we wrote is P over 100. So in that setting, then this will be what I'm writing. But remember, this is 0.27, right? So that's a question. Now, here is a basic thing that you may want to remember to make it convenient. If you're looking for the reference number, you always do the division of that part divided by the percentage written as a decimal. So in this case, how would you calculate this? Well, as I said, to find the space number B, what you have to do is to find the number that represents the part A by the percentage expressed as a decimal number, that's 0.27. All right, and so the answer to this question is going to be 3,000. And that makes sense, right? Because the population would be much bigger than 810 if 810 students make up 27%. It's about 4 times as much as that, because 27% is very close to 1/4, which is 25%. So you could sort of estimate that the answer would be about 3,000, and well, about 4 times as much as this, not quite, and 3,000 sounds reasonable. But the precise answer should be obtained by dividing the number A by the percentage written as a decimal. Hopefully it's clear. Okay, so these things need practice, and so that's what your homework is for, and your online quiz is for as well. Okay, if a ticket price is $30, okay, let's say ticket price is $30. You have to pay $30 to buy a ticket, maybe a concert ticket, maybe a theme park ticket. Definitely not a Disneyland ticket, because nothing costs $30 at Disneyland. Anyway, so but it has increased by 25%. Now the new price is what? Okay, so what used to be $30, but now it's increased by 25%. What is the new price? Okay, so well, what is 25% of $30. That's 0.25 times 30. Remember, 25% can be written as 0.25. And we are looking for the part that represents 25% of 30. And the answer is 750, 7.5. And so you add 7.5 to 30. And of course, the answer is $37.50. And this is the price, the new price, which is 25% more than $30, right? Right. Now, there's another way of expressing this, and I want you to understand the second idea as well. If the price 30% was the reference number, which is like 100% of 30, right? I mean, 30% is the reference number. If you add 25% to that, then what you're really looking for is 125% of 30. Did you get that? 30 represents the entire whole, which is 100% of 30. If you add 25% to it, you get 125% of 30, which should be the new price of this ticket. So how do you do that? It's 1.25 times 30, and that is 37.50. And that was, of course, the answer. Okay. See, the point is, if you do it this way, you don't actually have to do multiplication followed by addition, right? You can do all that in one shot. So, okay, the last question on the front part is, if a ticket price is $30 and if it's on sale for 20% off, the sale price is, all right, so what is 20% of 30? Now, notice here, 30% is the reference number. It is our base. It is our whole. And we are trying to calculate 20% of that. How do you do that? It's 0.2 times 30, and that's $6. Okay, so you will get $6 off. 30 minus 6 is 24, and the answer is actually $24. All right, let me explain the second way of doing this. Maybe you have already figured this out. When you get a ticket for 20% off, you are paying 80%, right? Because the whole thing is 100%. If 20% is discounted, that means you are paying 80% of the original price of the ticket. So paying 80% of $30, if you calculate 80% of $30, which is 0.8 times 30, you get 24, and that, of course, is the answer to the question. So here is a quick way of coming up with that answer instead of doing the multiplication followed by subtraction. All right, so these are some of the basic ideas involving percentages. Now we talk about a couple of applications. One is a change, and the other is comparison difference. Okay, both of which can be represented by percentages. And in fact, both the change and differences are often represented or expressed using percentages. So that would be our next clip. So go ahead and take a look at what's coming. And once you have some idea, then you can start looking at this next segment or the second clip of the video for section 2.1.